screen so I can see things. So yeah, so why don't we get started? So welcome everybody to the Collaboration for a Better World speaker series that's sponsored by the Department of Integrative and Global Studies. And today, as you all know, today's speaker is Professor Dustin Mulvaney from San Jose State University in California. And our co-sponsor for this talk is the Department of Civil and Environmental Engineering, and Carrick will speak about that in just a few seconds. Just a brief overview is we began the speaker series last year, and we're really excited to continue it and grateful for everybody making time to participate in it. Our intent with this Collaboration for a Better World speaker series is to bring speakers to campus somehow, remotely, in person, whichever way we can do it these times, that'll raise important cross-cutting issues about grand challenges and help us in the department and across departments think about these grand challenges. We hope the series will showcase collaborative research and collaborative action that'll spark new conversations that might lead to new collaborations on campus or across campuses and with different people. So I just wanted to give that quick overview. And Carrick, did you want to say a few words about civil engineering and
Sure.
yes. Yeah.
Well, our newly renamed Civil, Environmental, and Architectural Engineering Department is very happy to co-sponsor. This is very much directly along the lines that our department is moving in terms of just infrastructure generally and energy transition and how we power everything. The carbon emissions and energy impact of buildings and infrastructure is huge. And unless we solve those problems, whether it's the energy sources or how we get concrete-like materials and things like that, we cannot solve the climate problem. So we're very interested and welcome you, Professor Mulvaney.
Yeah. All right, great, thanks. And so I'll just briefly introduce Professor Dustin Mulvaney. So again, he's he's a professor at the Environmental Studies program at our department at San Jose State University. And his research is on governance of emerging technologies in both food and energy systems. He's thought about several different commodity chains in that regard, and with most of his recent focus on photovoltaics, supply chains, and the socio-ecological impacts across the life cycle of solar systems. He has a recent book called Solar Power Innovation, Sustainability, and Environmental Justice. He's also written a new textbook about sustainable energy transitions, socio-ecological dimensions of decarbonization. And I guess he also has another textbook in the works called Energy, Society, and Environment, a critical introduction. In his
that book got delayed.
Yeah, well, okay.
But it's coming. It's coming. My publisher's been asking for it, so it'll come.
Well, I must have hit the button by accident. Okay. Yes. Thank you.
Well, thank you for the invitation to talk with your group here. What I intend to do is give you a little bit of kind of why I got into this space and why I found this to be a compelling topic for research and activism. I would consider myself a scholar activist. I work and collaborate with environmental groups all the time on various elements of mainly energy systems, as you said today. But I'm going to really walk through three different categories of impacts and the things that we should be thinking about as we develop and scale this technology to terawatt levels and beyond, which is really what we're talking about when we are talking about a solar energy transition, providing a large portion of our energy supply or our electricity supply from the sun. And the concept that, from a life cycle assessment perspective, which is very similar to a commodity chain analysis, except it's really interested only in the material and energy flows, not necessarily the people, which is ironic because it's life cycle assessment, but I mean the life of the product, of course. This idea of embodied energy is a concept that should be familiar with people who study life cycle assessment. The idea that there's energy embedded in the production of an object. And for a renewable energy technology, that's important because you want to make sure that the energy you invest, you get back out of it. And that was kind of the impetus for even designing that metric when they started thinking about that. Oh, I'm not sure even when, but 50 years ago or so. But more recently, thinking about how justice or injustice might be embodied in the materiality of in this case, the photovoltaic cell or a solar farm, will be what I try to introduce today, and focusing on labor, land, and waste as the three areas that I think deserve a bit of attention as we scale this technology, because we're really only talking about a small percentage of our electricity supply coming from the sun today, and that's growing. But to scale it to what we need, we're going to have to ramp up chemical production and glass production and all sorts of other things that are going to mean different landscapes come under pressure, right? And that's partly true also because we're moving from using subterranean energy sources, which you just kind of build a little well pad and poke a hole in the ground and get your many megajoules of energy out, to one where we harvest energy from the surface of the earth. So in many ways, there's a lot of concern about energy sprawl, which is why we'll talk about land. But how I got into this, I was thinking about this, and I actually found the article that spurred me into thinking about this as a research topic. Oops. This was in Nature in 2006. And it was about the emerging thin film industry that was coming to Silicon Valley. So thin films are a type of solar panel that's made with a very thin film of semiconductor layer. And at the time, there were several dozen startup companies in the Bay Area of California, and I was looking for a local project. And I had read a book called Silicon Valley of Dreams, which was about a prior clean tech era. That's a book by Park and Pello, and they were studying the rise of the semiconductor industry in the 60s and 70s in Silicon Valley and what the consequences were there. And the legacy, of course, everybody wants to create a Silicon Valley, right? Everybody wants to be the next Silicon Valley, but there were some consequences that kind of get masked in that otherwise, success story of how a vibrant economic system can emerge in a region. Everybody wants to study Silicon Valley to be the next Silicon Valley. And I know the East Coast has their own little 128 corridor that's kind of similar in that regard. So I was interested in this, thinking through the Park and Pello lens, where clean tech meant clean manicured campuses with no smokestacks, and it was an industry that was supposedly better than the dirtier industries of the past, but clean really meant keeping the product clean. To clean tech as it's interpreted today, which means low carbon, and thinking about what and looking into what these thin films were made out of, seeing that they're all based on some heavy metal that was toxic, most of them being cadmium. So there immediately drew my attention to think about environmental justice issues with scaling this particular technology, because it would mean scaling up, the use of a toxic metal in a product for energy production, which has its own consequences. Now, it's a very short-lived time period where this idea that Silicon Valley would be, a clean tech hub manufacturing solar panels basically disappears within a couple of years. And that has to do with the entry of, mostly China as a major photovoltaic manufacturer, but some other countries now as well, Vietnam, Malaysia, where we see lots of production. Lots of contract manufacturing where they do things a lot cheaper. And they were using the old technology, which was the crystalline silicon solar cells that were developed in Bell Labs in the 1950s. So that kind of, in some ways, shifted at least the imaginaries of what the solar industry would be based on, from one where it's, US manufacturing, but it's got a toxic metal in it, to the old style of crystalline silicon, which we have been using and continues to be 95% of the industry today, probably 97, 98% of the cumulative solar panels ever made are crystalline silicon. Thin films really never took off. Although these articles that were coming up around 2006 were saying by 2020, thin films would be 90% of the market and stuff. But that shifts rapidly with the shift in the global production scenarios and how things changed. Now, I'd mentioned this idea, embodied energy, and the analogous idea introduced by Healy et al. In 2018 to think about embodied energy injustice along the commodity system. The idea that there might be human rights abuses, or there could be unworkable labor conditions or extractive industries that pollute their communities in the supply chain for a product that we otherwise are trying to encourage. Right? If you look at all the major environmental groups, they just want more solar panels. They don't want to talk. The climate conundrum we find ourselves in has kind of winnowed away concerns about hazardous waste and the manufacture of products in this case, because this is the technological savior that's going to help us displace our fossil fuel use. And I think there's a lot to be said that partly is true, that these technologies will displace a more polluting industry. But it can also be true that they may, these new commodity chains, as they develop, might reproduce the social inequalities and environmental inequalities that we see in previous production systems. So thinking about this as a manufactured product that could be made better is really how I try to frame a lot of this. And if there's one thing I don't want folks to walk away from this talk thinking we should just stick with fossil fuels, because that's definitely not what I'm saying here. I'm suggesting that there are places that we probably should be focused on thinking about making the product better. And that's what I hope to do in the next few slides, or I'm sorry, in the next hour or so. So semiconductor supply chains, these are the two dominant technologies we have out there today. To the left is the crystalline silicon that I mentioned before. That's the technology where you start with quartz and you process that into a silicon metal, and then you further process that into something called polysilicon. I'll explain this in a little more detail. And then eventually made into solar cells, modules, and then eventually integrated into a solar farm or a rooftop array or wherever it ends up. That process, one of the reasons that thin films was seen as attractive was not only because the material could actually be thinner, so you have less semiconductor material by 100-fold or more, which can significantly impact the production cost, but also that the way that crystalline silicon solar cells are made is more of a batch process, meaning you make a batch of the metal silicon and you ship it off to another place that makes a batch of the polysilicon, and another that makes the cells and the wafers and so on. The attraction of thin films was that you could literally put a piece of glass in one side of the factory and move along on conveyor belts, layering semiconductor layers such that at the end of the day, you have a solar panel that's ready to be shipped off and put into some sort of array or solar farm. So it was not only about the fewer materials, but also a production process that could be continuous and much more quick to apply those materials. If we look at what the dominant thin film technology is, really only one major manufacturer today. That's a company called First Solar, and they make a cadmium telluride solar cell. Cadmium, obviously being a very toxic metal, is very similar to the ones that were in the Bay Area at the time, which was actually a different thin film mostly, but also had a cadmium semiconductor. And tellurium, interestingly, one company uses 40% of the global supply of tellurium, one solar company, which is quite impressive. So meaning that if we want to scale that CadTel technology, we're going to have to probably pull some more tellurium out of the copper ores where they're typically found. And we see some evidence for solar, for example, contracting for that. Let's bring that up in a few. The other interesting thing about this particular thin film is that, we think about the mining impacts of the materials we get from the mining impacts. It's hard to associate with the secondary and tertiary products of a mine. So the primary activities for cadmium production are zinc mining, meaning that even if the cadmium wasn't recovered, probably the zinc mining is going to happen anyway. Same thing with the tellurium. Even if the tellurium is not recovered, you're probably going to have some of that copper mining anyway. So that's just to say it's hard to have cause and effect with understanding whether when you take more materials, you're actually causing more mining and such. Here's just another diagram showing the same thing on the crystalline silicon side. Silica, there's a metal silicon step in between there, not shown. polysilicon, and polysilicon is going to be important in a few minutes because that's really the first step in the solar supply chain. Most silica that's mined goes to other industries. Most silicon metal that's produced from that silica is sent to other industries, but it's really the polysilicon production where we see solar grade polysilicon. For many, many years, actually, and one of the other reasons that thin films were seen as attractive was that the crystalline silicon that was used for solar cells was transistor quality, meaning it was much, much more pure than it needed to be. And the industry relied on discards from the computer industry for many, many years for that reason. So as they were ramping up solar grade polysilicon, that's when the thin films entered into the story in those late 2000s or so. Various stages until that cell is made. And then at the end, you have other supplies of other materials coming all together to make that solar module. You have specialty chemicals, you have bulk chemicals, you have an encapsulant that goes on top. It's a really thin, clear plastic layer. You have backsheet. That's usually a hard plastic material like Tedlar is a common one there. And then glass. The solar PV module at the end of the day is mainly made out of glass. So 70 to 80% of the weight is going to be glass. So thinking about that life cycle perspective, if you want to be closing the loop here, figuring out a way to recover that flat glass is going to be a really important one. This is what quartz mining looks like. These are from a very, very important mine in North Carolina that supplies a very large portion of the global semiconductor quality quartz. So there's a lot of silicon in the world. Our Earth's crust has a lot of it. We've got a moon made out of it. So we're not going to run out of silicon, but the high quality, I'm not suggesting mine the moon. The high quality, high purity silicon is actually much, much less available. And in fact, this one, for many years, this one mine produced nearly all of the semiconductor grade silicon in the world. It's changing now as other resources are being developed, and other countries, some countries are sitting on their quartz deposits until they develop industries where they can do the value added to then export final products as opposed to exporting quartz. So this is a little bit of a complicated commodity chain, but it is, again, very concentrated, very few players in that space. And as you move down the commodity chain, that remains the case. This is a polysilicon refinery where they purify silicon metal into polysilicon. It's a pretty neat process. It involves these chemicals called trichlorosilanes. And those trichlorosilanes are basically a gaseous form of silicon that gets deposited on these rods. These are crystal, the picture to the upper right there is our polysilicon rods produced in a Siemens reactor, our modified Siemens process technically. And those rods are broken up into polysilicon chunk that you see down in the bottom right there. And then that's further melted down one last time to make a big crystalline ingot in the case of monocrystalline silicon, which is a little more than half of the industry supply today. But these trichlorosilanes, so trichloro means you got 3 chlorines around your silicon atom. When you get a 4th chlorine, it's called silicon tetrachloride, and that's waste. That's a waste product. In fact, even the trichlorosilanes, they're very reactive with air and water. So we've had some explosions caused by trichlorosilane up the chain. But the tetrachloride, silicon tetrachloride waste has been documented to be a problem in some parts of the world. Now, at the time, late 2000s, much of the manufacturing of polysilicon is still happening in Europe and the United States. So this Washington Post article you're seeing to the left there, that's an early polysilicon facility that was built in China, where they were not recycling or recovering the silicon tetrachloride waste. The reason that silicon tetrachloride waste is recovered is because it's already very, very purified. And it's really easy to strip that chlorine back off and add it back into the production process. But at the time, these factories were ramping up. They were not adding this particular unit onto the production process. So they were literally dumping silicon tetrachloride waste in farmers' fields outside of the factory gate. Now, a couple years later, China passes a law that requires them to recycle silicon tetrachloride waste. So we don't see this particular incident happening, but we are left with an industry that's relatively concentrated geographically and by firm. So there's really 6 major polysilicon producers. And that's one of the unique things about the supply chain for solar, is that the top part of the chain is very, very concentrated, and it gets more dispersed as you get close to the modules. So there's a whole bunch of module manufacturers. There's only a handful of polysilicon manufacturers, and that creates some challenges if you want to pressure your supply chain, for example, to be cleaner, right? You think about Walmart. Walmart can say, hey, you want to sell your product in our store, you have to do X, Y, and Z. In the case of a photovoltaic module maker, if they say they can't really talk upstream to their polysilicon producer and say, hey, you need to make it this way, because they'll just say, well, we'll sell it to somebody else. So the dynamics of the supply chain are a little bit different there. This is 2018 data or 2019 data, 2018, and it's showing the geographic concentration of production. I mentioned earlier that China was just really starting their polysilicon and wafer production around this time period. But if we were to look at it today, it dominates polysilicon production. There's still some in Europe and the United States, but it really dominates wafer production. So even polysilicon that's produced in the US is sent overseas to be made into wafers, and then they stay in maybe in that country or to other countries for the cell and module manufacturers, and we end up importing much of those things. So these are, again, the wafers to the solar cells to the module, essentially. That's how those pieces come together. Now, if I were to flag another piece of the supply chain that's probably really important for solar manufacturing, it's silver. If we look at deployment, for example, and how much solar you can deploy, it's not limited by the silicon. As I mentioned earlier, we got plenty of silicon, and maybe even semiconductor quartz, we have plenty of that, but we don't have plenty of silver. And right now, the solar industry, depending on how you measure it, is using somewhere between 15 and 20% of the global silver supply for their PV modules, where it's in the metallization pastes and things like that. So it's used as a contact there. Now, this again doesn't necessarily mean that we're mining more silver for solar, because if we actually look at the increase in silver demand from the solar industry and the decrease in silver demand for the photographic industry, not photovoltaic, photographics, pictures, cameras, film, they used to use silver to help process that. And that basically has swapped out. So the amount of silver waste from the photographic industry has been, silver used by the photographic industry has basically been absorbed now by the photovoltaic industry. One more piece, or two more pieces of the supply chain we'll talk about that are really important, and this is glass. So glass also comes from quartz, different quality of quartz, and we're going to need to grow our flat glass industries pretty severely. Glass production can also have a lot of silicosis in it. So glass dust, working in a glass manufacturing facility can cause what's considered to be one of the oldest occupational illnesses, which is exposure to silicon dust inside of a facility or building, whatever they were building thousands of years ago. And we're starting to see some crunches here too. So we had a glass shortage last year, which we believe helped drive up prices, because now you have companies competing for less available glass, but possibly even a shortage of the factories that are needed to complement this. Usually when a photovoltaic facility expands, you're going to also expand glass production nearby somewhere, and these are usually pretty near to the manufacturing. Last couple little bits here for what goes into a solar panel on the crystalline side: aluminum frames. Now, if we look at a solar panel, I mentioned earlier, it's mainly made out of glass. If we were to say, well, what's recoverable from that? The aluminum and the silver turn out to be about half of the value of that solar panel. So aluminum frames, much of this is recycled alumina is one of the materials that we have a little better recycling on, but there is some bauxite mining still that occurs. And I have gallium up there because gallium is also used in a different photovoltaic industry technology, but I didn't mention those yet, so I won't dig into that one. On the thin film side, I'd mentioned earlier that cadmium is a byproduct of zinc mining. So again, if we were trying to understand what are the impacts of using cadmium in photovoltaic cells, we want to understand what the impacts of zinc mining are, because that's the primary production process. Similarly, copper. This is a picture of the Bingham Mine outside of Salt Lake City in Utah. If you've ever been to Utah and fly in there, you'll see this mine. It's, you can see it as you're circling the airport. One time I flew in there. Here's a recent newspaper article from PV Magazine where First Solar is announcing a contract with Rio Tinto to gather more tellurium from the copper mine there, because again, they're using 40% of that supply. And that's a risk to their investors. They have to talk about, like, that's a market cap for them. They have to say, well, we're limited in our growth because there's only so much tellurium in the world, and that's why they actually recycle their panels too. So we're going to see probably more announcements like this, where secondary and tertiary products and mining activities are ramped up to go after some of these other elements. I'd mentioned the three areas I think that are important to look at from a sustainability perspective moving forward are labor, land, and waste. And we'll start with the labor question, because that seems to be the most pressing issue the industry is facing right in the near term. Right now we have a situation where there are allegations of forced labor in the solar supply chain. So in Xinjiang, which is in Northwest China, that's where much of the global polysilicon is produced. Actually, it's 45% of global polysilicon is produced in Xinjiang. There's no human rights organizations aren't even on the ground anymore in this area. So we actually have no window into what's happening in these production facilities. We know that there have been some explosions because that took off some of the production a couple of years ago, but that's not really what we're talking about. We're actually talking about forced labor for ethnic minorities. And this is a topic that's outside of my expertise, but it's something that, it seems critically important for us to understand and get a handle on whether or not this is occurring, because we can't have, this is probably the worst case scenario of ignoring what's going on in your supply chain and then suddenly finding out that half of it's coming from an area where you have forced labor potentially. And it's actually even more complicated than that. The failure to have traceability in the solar industry has led to a situation where this went unnoticed for a while, but it also means that we actually don't even know how. So 45% of the polysilicon supply does come from this part of the world, but we don't, it might be in all the modules, because what happens is there's actually also a spot market. So manufacturers contract for their polysilicon, so there's kind of a direct line, but then there's also a spot market where, like, if you produce extra and people need extra, people are buying it, meaning that this polysilicon is getting blended into more than 45% of the modules. We have no idea what portion of the modules. And just this week, a second company was named, and they're actually seizing shipments of photovoltaic modules in the port of Los Angeles that are suspected of coming from these particular regions of the world now. So we've walked ourselves into a very, very awful situation where we want to grow this industry. We have no idea which modules and how many might be linked to this question of forced labor. The forced labor issue itself might be something that's, being geopolitically positioned in a way too, that, it's hard to really understand what's happening here. But it certainly raises a lot of questions, and we should be thinking about that a little bit more. The other caution or problem, I would say, with this particular supply chain is that many of these polysilicon manufacturers, when they set up, they literally built coal-fired power plants to power them. So this is the most energy intensive stage of the manufacturing process, and it's powered by coal. So if we're talking about reducing the impacts of our products, this is probably one place that we can make a big dent in the impacts if we can get polysilicon production to be off of coal. Because of that, that cascades, that affects the carbon payback, that affects how many years it takes for your solar panels to generate electricity before they start paying off their greenhouse gas emissions that are invested in them, similar to the energy payback time or embodied energy concept before. This is a study from Argonne National Labs that looked at module manufacturing, comparing Europe and China, and what that carbon intensity associated with that production process. And you can see it's about double. So the carbon footprint of a solar panel made in China is about double that made in Europe, according to these numbers. Now there's a new group of manufacturers. These are US-based manufacturers largely. They're called the Ultra Low Carbon Solar Alliance. Because one of the ironies of this shift in global production from the US to China was an increase in the carbon intensity of the polysilicon because of those coal-fired power plants. Much of the polysilicon prior to that was being made with in grids with a lot of hydropower. So that was much lower carbon. And of course, these manufacturers are now trying to capitalize on that. Many of them have mothballed factories, or they're not selling to the solar industry anymore because they can't compete. There's a trade war that's in the background here too. That's important. The US put tariffs on modules coming from China. And then China put counter tariffs on polysilicon going to China. So we've had quite a dynamic situation, probably shaped by the trade situation. I mean, you can make the argument that putting tariffs on modules coming from China ended up pushing polysilicon manufacturing or scaling polysilicon manufacturing in Xinjiang. So there's kind of almost a direct line of seeing that area grow in polysilicon production post putting tariffs on that polysilicon. So unintended consequences sometimes. So today now the PV industry is trying to figure out how to trace. This is something I've been working with an organization called the Silicon Valley Toxics Coalition for over a decade now on this topic of transparency in the supply chain and thinking about where materials come from. And here they are finally in 2021 realizing how important it is to figure out where your materials are coming from. So this is the Solar Industries Association's Traceability Protocol 1.0. Here we are in 2021. They probably should be on 5.1 or 7.1 or 7.3, whatever. They should be much further along, but they unfortunately are in a really tough situation. Now, the US labor situation is a little more complicated in some ways because, when we did have manufacturing here in the US, module manufacturing was not union labor. It was largely made with temp labor, not even like just, employees that aren't unionized. They were actually using temp employees often for this module manufacturing. So that is complicated. And then when we talk about the installation, that's really where solar jobs are in the US, is not in manufacturing, but in building power plants, installing solar on rooftops and things like that. That's complicated too, because usually rooftop installers are going to be smaller companies. They're not going to be unionized labor either. Whereas big construction companies like Bechtel, they're going to have unionized labor. So this in some ways is where, when you say we want union labor in our solar workforce, it's going to lead to a particular configuration of solar. In this case, it's going to lead to more utility scale solar over rooftop because that's where the union jobs are. It also, given what we do in the American West, which I'll get into next, and how we treat land out here, it also has caused some occupational illnesses in those construction workers. And I call them construction workers, not solar workers, because they'll build a solar farm, and that will be a green job, but then they'll move over to build a bridge or a highway next, because that's what those construction companies do. So in some ways, again, advocating for making sure that there's union labor in here is reproducing a certain kind of solar farm or a certain way of producing power. It's going to definitely lend more toward utility scale than rooftop solar, and that has some negative consequences. This occupational illness, by the way, is called valley fever. It's an illness that we get out west. It's common with agricultural workers. It's a soil-borne pathogen that causes pulmonary distress. And it's a kind of a debilitating illness. It's funny, when I would first go to public hearings on solar farms and heard people talk about valley fever, I didn't know what it was. I thought there's like chemtrail people that come into the meetings to talk about like stuff that wasn't real, but it turns out that it's very real. And now we have case reports from the Centers for Disease Control documenting this illness. Now, as I said, in the American West, we tend to have an approach to building solar farms that removes all vegetation and scrapes the topsoil. There's the caliche, which is the biological crust on top of the soil, to bury burrows. We make the landscape very, very homogeneous and easy for workers to get around in these landscapes. And that means turning large parts of the landscape into areas that lack vegetation, which also causes more dust in the area, and that causes more valley fever. That's kind of a side effect of that. But this particular project, this is the Desert Sunlight Project. This is the largest power plant in the United States. It's 550 megawatts. That's only a little section of it you're seeing there. That's what it looks like when it's all built. That in the background there, that's Joshua Tree National Park. And this solar farm has about 9 million solar panels in it. So it's a very large solar farm. It's about 10 square miles. It would take you a long time to walk around, bring plenty of water if you ever try that. Now, the other thing going on in the American West is that we have a lot of public lands. And these public lands have been advocated by policymakers to be the lands that will be made productive by getting solar power on them. The idea being that we gave oil and gas public lands for so long, why don't we give the solar industry public lands? And that's caused some problems too, because our public lands, they're kind of in conservation by default. They were never developed. In fact, one time the federal government tried to give them back to the states. The states are like, we don't want that. That's just wasteland. That's not, we can't develop agriculture on that. Maybe if there's some mining, they grab that. But now that there's a resource there, which is the sun, they've come under quite a bit of pressure. This is an organization called Basin and Range Watch drew this cartoon. At one point at the peak of applications in 2010, there were more acres of solar planned for development on public lands than have ever been given out to oil, gas, coal, or hard rock mining on public lands, which is unfathomable at one scale, but makes sense given how large some of these solar farms are, 10 square miles in some cases. So what we see as a result of that is only maybe 3 to 5% of that is actually developed. And we had a whole bunch of reasons that particular model was pushed for. One, again, we have new markets being created for renewable energy. I mean, states have a renewable portfolio standard to meet. That means the utility has to buy a certain amount of electricity from renewable sources. And it turns out that these utility scale solar farms can be much cheaper than a net metered rooftop solar array on a roof. So that's one of the reasons we saw these pressures on public lands. We also had quite a bit of finance made available. I know Congress is supposedly going to vote on some big bill, infrastructure bill soon. We did that once before, and we spent nearly $90 billion on clean tech investments through the American Recovery and Reinvestment Act, which had a bunch of loan guarantees. So we saw also that one other reason these projects were put on public lands was they could be built in time to spend the infrastructure money. And that's partly because they were able to fast track the applications and expedite the environmental review on public lands. So that's one of the reasons that public lands were targeted for solar development so strongly in that time period. the other reason, and the reason that I mentioned that policymakers were advocating for the development of public lands in 2005 under the Energy Policy Act of 2005, they invited the BLM to have a mandate. They didn't actually use the word mandate, but the idea was that BLM would develop 10 gigawatts of solar on public lands. That number's been cranked up to 25 gigawatts now. So policymakers seem to be very, very gung-ho about building solar farms on public lands as they continue to ratchet them up, and maybe not taking as seriously some of the environmental consequences of doing that, or looking at the alternatives, which I'll get to it in a little bit here. So this is a picture. This is Silurian Valley. This is near Death Valley in the Mojave Desert. And as you can see, it's an unproductive space, right? It's not doing anything for human civilization. It's just there. It looks pretty, has some species in it. But these are the landscapes that can be easily fragmented. So you imagine dropping a 10 square mile. This is a project that was denied actually and was not ever built. But you can imagine dropping a 10 square mile solar farm in here is going to fragment that habitat. It's going to disturb the land itself, especially if you bulldoze it, as I suggest it happens here. This was a different solar farm nearby where there was concerns that it would fragment the habitat and crossing for bighorn sheep. Bighorn sheep like to be able to intermix, otherwise they get inbreeding depression when they get isolated populations. So habitat fragmentation is another major thing that people are concerned about out in the Mojave Desert. As our cultural resources, so our public lands, there's memorandum of understanding between tribes and public land managers that they will get prior consent, or at least they'll do some outreach early on in the process to get their feedback and input into development processes. We've seen quite a few projects disturb cultural resources. We had a project called the Blythe Solar Project that damaged some geoglyphs. These are, they call them intaglios also. These are stick figures essentially of human and animal images that we didn't even notice until we were flying around in airplanes, but they're all over the Colorado River Valley along in the California side. And then we've also seen in one case, a Genesis solar farm, they found a cremation site. So, a failure to consult with Native American tribes has led to some damage to cultural resources as well. The species that you may have heard about out west that gets the most attention around solar farm development is the desert tortoise. It's clearly a remarkable animal that lives in the desert and it lives in these holes. It's lived out in this area since it was actually tropical. So this animal lived alongside saber-toothed cats and all sorts of stuff. So it's also got some challenges facing it from climate change. But now this is its population. It's lost 90% of its population in the last 50 years or so. It's rapidly losing its habitat to suburban sprawl from Las Vegas, California. And it's in the case of the public lands, we're disturbing quite a bit of its habitat with solar farms. There's quite a number of solar farms that have required the translocation of desert tortoise from one place to another. They do not do very well there. They have very high rates of mortality associated with translocation. These are animals that can live up to 100 years. So just picking them up and moving them somewhere else, they don't do very well. So this is the new challenge. Now, when the BLM had this mandate to develop their public lands for solar, it started at 10 gigawatts. They soon realized that it would be better. They opened up 21 million acres across the American West and said, first come, first serve, wherever you want to put a solar farm. We'll consider it and look through the process. They eventually decided to do what's called a programmatic environmental impact statement across the West. And the idea there was that they would look at that 21 million acres and they would zoom in to certain parts of that 21 million acres and try to find low conflict sites. Now, it's hard to find low conflict sites on public lands in general because they're, like I said, in conservation by default. But the idea was that if they could figure out where there's relatively disturbed public lands or degraded public lands, and they could establish what are called solar energy zones, that would allow for better planning and the outcomes would be better for the desert and for the solar industry. They would understand where they should be putting their projects because they don't want to pursue a project that's not going to get built either. So this is the Riverside East Solar Energy Zone. This is along the Colorado River. It's really far on the eastern side of Riverside County, which, you know, goes all the way almost to Los Angeles. It's a very big county, but now that's why they call it Riverside. It's right on the Colorado River. And this particular solar energy zone, you know, has quite a few solar farms in it now, but it's not being developed further because the transmission is saturated. And it turns out when you're trying to figure out why are they putting solar farms where they put them where it's easiest to get access to transmission. The cost of interconnection turns out to be a really, really big ticket item if you're not close to a transmission line. So California's quest for coal in the 1970s on the Colorado Plateau, 1960s, 1970s, they built transmission lines across the public lands to get to that coal. And guess where all the solar farms are going? Right along those transmission lines. So in some ways, you kind of have this legacy infrastructure that's shaping the conflicts we see today because that's where the projects are being cited. We are seeing, so for many years, I would give this talk and say, solar energy zones solve the problem, great job planning and all that. And then suddenly we see talk about more stimulus money, which they're voting on today, I think. And about 2 years ago, I just started seeing large numbers of applications again coming on public lands. Again, I think it's partly because they can get these projects built in time, meet all the milestones, the groundbreaking to get the different tranches of money. And we see quite a few projects that are being cited in I'll just be honest, in very terrible sites for solar farms, terrible for the desert tortoise. The Yellow Pine Solar Project is one of these. Gemini Solar Project is another that's right on a reach of Lake Mead, where they have like 6 groundwater wells they've dropped there. Yellow Pine Solar, interestingly, is right on the California border, where in California, desert tortoise is an endangered species, but it's only threatened in Nevada. So Nevada, again, is a little bit of the Wild West. And that's where we're seeing much of the new development, actually, even for California's power supply, is in Nevada, partly because Nevada, they're excited to develop their public lands. They take a very different view, not the whole state of Nevada, but the public officials. They see that as a potential for revenue generation. I should say that San Bernardino County and Riverside County, which are the 2 California counties right in that area, also are very excited to develop public lands because the counties don't want to see their own land go under solar development because they don't get property taxes on solar farms in California. And they want to leave that open for other kinds of development. And they think public lands are there for this kind of extraction, which is land use for solar. Now, I've been talking mainly about the projects themselves. There's also land that's required for mitigation if you develop land that is habitat. And sometimes this can be abandoned farmland. This could also be the public lands that we're talking about. So what happens is a solar developer might say, hey, I want this 5,000 acres of desert tortoise habitat. And as a condition, the mitigations might require that they buy 1,000 acres of desert tortoise habitat and put it in conservation in perpetuity or something like that. Some of the ratios I've seen were 5-to-1 for kit fox, another really small little dog that lives in California. So the land acquisition, or the land associated, I should say, with solar farms is also tied to the land that's needed to make the mitigations happen, meaning that the footprint of a solar farm is actually a lot bigger. And maybe folks would say, well, but they're protecting that land also. And that's a little bit of a challenge also because, you know, some mitigation lands are stopping development. Other mitigation lands probably were never going to be developed. Meaning, let's say I want to develop a solar farm and I say, I'm going to go protect 5,000 acres on the moon. Probably not developing that soon. I'm probably going to sound outdated pretty soon, but when we start our space mining. But so point being that there are such things as false mitigations. You might think you're getting more habitat, but you're really just keeping stuff, you're just on paper keeping stuff out that wasn't really going to be developed anyway. There's another interesting wrinkle in this, which is there might not be enough mitigation lands for some of the species if we want to meet goals. So California has a lot of abandoned farmland that's being targeted now that we are in somewhat agreement that as a collective in the state that we shouldn't be developing our public lands as much, and we should move more to agriculture or more agricultural land. Some of those agricultural lands are important habitat also. So for example, this is the Swainson's hawk, which is an amazing bird. It flies all the way to Argentina every year and comes back. It's amazing. And it's losing a lot of habitat as farmland gets turned into suburban sprawl throughout the state. It's also one of these species that requires habitat mitigation for solar farms. And we actually don't think there's enough mitigation land to develop the solar necessary for California in this particular case. Not only that, but as you can see from that biological Center for Biological Diversity press release, sometimes mitigation funds get given to the county and they don't spend it on mitigations. So in this case, that's which county? Kern County, of course, it's Kern County. Kern County, they rolled their mitigation funds right into their general fund to pay for whatever other things the state needs or the county needs. So, you're not sure you're actually getting the mitigations at the end of the day. They sign off saying that they're going to give the money, but it's not sure that it actually hits the road the way it should. Now we have all sorts of alternative places, and that's really where I think we should be trying to figure out ways to incentivize developing these particular places. So the EPA, US EPA tracks parcels that are brownfields, abandoned mines, abandoned landfills, Superfund sites, and screens them for whether or not they could be useful for solar development. They're not looking at transmission interconnection, and that turns out to be the important piece they'll be looking for. But they have identified more than enough lands to develop to meet the solar needs for different parts of the country. And I have never looked at all the states, but I know in California, for example, they got close to 500 gigawatts worth of degraded lands in their database. And California's peak power is around 40 gigawatts. So even if we went a little bit beyond that, that's almost 10 times as much land available for solar as is needed for solar. So there's plenty of that available. The issue again is parcel size, right? Can you build a big enough solar farm that an investor would want to actually build it? But key being interconnection. Are these things close to substations, and are they close to transmission lines? This is a paper I was a co-author on by Rebecca Hernandez's lab, and Rebecca Hernandez does amazing research on this topic of land use change, prolific lab producing all sorts of amazing research. So I feel lucky to even be considered as an author on this paper. But we looked at acreage across the U.S. and potential degraded sites to alternatively put solar as opposed to developing our protected areas or public lands that are in pretty good shape. Or even again, we have agricultural lands under something called the Williamson Act, which is kind of a conservation easement type process, and even those are being developed, and that's a problem for habitat as well. So in this paper, Rebecca and the team promote this idea of technoecological synergies and trying to think about how can we get more this is the only technology we can live under, and we could put other kinds of infrastructures under that generate electricity. So like, how can we start to see more of this on the landscape? How can we produce food and energy together, for example? Or how can we create other value-added products on landscapes that might be generating just solar power today? I've seen a really neat setup somewhere in Asia where a photovoltaic farm that they have floating on water is over aquaculture production. And you can see the picture in the upper left-hand corner is from India. And California finally has set some money aside to start cut. We got a lot of canals in California. Arizona has a lot of canals, and those are losing a lot of water from evaporation as that water moves around. So you could see a lot of opportunity here. You could probably get cleaner water out of it if it stays cooler, less algae growing in it and all that stuff. So thinking about how do we facilitate these kinds of scenarios. Now, last topic I'll touch on briefly here is waste. That's the end. So labor, land, and waste. And waste is important because photovoltaics have that recipe for electronic waste, which is that they got some valuable metals embedded in toxic materials and sometimes toxic metals. This is from Hurricane, I think, Maria in Puerto Rico in 2018. So photovoltaic modules fail for all sorts of reasons, factory mistakes. In this case, this is a hurricane. We've seen tornadoes, hail, manufacturing extrusions. That's the word I was looking for. So we have a whole, we're already starting to see some of this waste show up. And because of the long life of the solar panel, where it's 20 to 25 years, we know that we can kind of project when waste will start showing up. Understanding that some might show up early from a hurricane like this too. So IRENA and the IEA in 2016 did that exact thing. They projected what they expect the waste flows to be based on what the deployment of solar would be. So these numbers actually need to be ratcheted up because they were using EIA data from like 2015 about what the solar deployment curve looks like, and that's already gone up. So we're probably going to see larger amounts in this. But what they project is that PV waste is going to be nearly 10% of the overall e-waste flows by 2050, which obviously doesn't swamp overall e-waste, but it adds to the pile of stuff that we're going to have to contend with here. Now, some places are already thinking about what to do with end-of-life photovoltaics. So in Europe, I mentioned PV Cycle is this entity in Europe that was set up to do a take back and collection program across the continent. And today we see 95% of PV modules are being recycled. It really means taken back, and that doesn't necessarily mean that all the materials are being pulled out of them, but at least 95% of the PV modules are collected. And that's because in Europe they have the WEEE directive, the Waste and Electronic Equipment Directive, which requires that they collect all electronic waste, regardless of whether it's hazardous or not. In the US, our waste management is basically about hazardous waste. We only care about electronic products if they're hazardous. And that turns out actually to be a very complicated question for photovoltaics. We have some photovoltaics that are hazardous. What they do is they grind them up into small pieces, and they simulate landfill conditions in the laboratory. And the idea is that if you pull a lot of toxics out of that material, it's hazardous. If you don't, you don't. So with photovoltaics, we have some that aren't hazardous. We have some that are hazardous according to the federal test, and then we have some that are hazardous according to the California test. That might not be hazardous to the US test. So it's super hard classification thing. And one of the neat things that we learned from recycling in Europe was when they did set up a take back and collection program, and initially set up in 2007, it really didn't take off for another 5 years or so. They found that a lot of PV modules were being reused. So just the act of collecting PV modules facilitated a reuse market in PV, which was pretty interesting and unique at that time. So how do we make solar better? I don't have any answers here. No, we got to think about how to make the jobs better. We have to eliminate forced labor in supply chains, make these better quality jobs. We have to think about making solar farms lighter on the landscape. We have to think about recovering and reusing materials or the photovoltaic modules themselves in new systems to kind of better facilitate these circular economy ideas as well. And the question is, what are the tools we have to do that? Now, in many other product systems, you have supply chain pressures that could be from consumers. Consumers might say, I'm not going to buy that. I'm going to buy the sustainable version. But solar power is mediated by different actors. So consumers don't have that same leverage. If you even invite someone to give you a quote for solar on your rooftop, they're probably only going to give you 2 different module options. They might even only give you 1 module option. So it's hard to leverage up the supply chain in that way. We also don't have a lot of social movement activity. That's the other way we get industries to change, is for social movements to say, hey, we want you guys to change the way you make this particular product, and we're going to be loud about it if you don't. And because of the concern about climate change, most big environmental groups are advocates for more solar power, and scarcely any are saying anything about better solar power. And I think that that's important. The last thing I'll talk about here is something that we have started to think about, the role of purchasing. So the National Standards Foundation International, in collaboration with the Green Electronics Council, has developed a sustainability leadership standard. And the basic idea here is that a company would go through and document their practices around 12 different areas of sustainability, including design for the environment, end-of-life management, conflict-free mineral sourcing. And these would appear as a whitelist. The modules that met these criteria, they'd get kind of a gold, silver, bronze, and they would be listed on a whitelist called the EPEAT registry. Now that's already in place for computers. In some states, like the state of California, says you have to buy a sustainable computer. Well, you just look up on this EPEAT list, and the university has to buy off the EPEAT list. So this general idea might be one mechanism to encourage purchasing to drive a little bit more of the sustainability standard. These are the categories that we have in there: substance management, preferable material use, so it's like recycled content, packaging turns out to be important. So a whole bunch of categories, and I'll make sure I share the slides so you can look at this more carefully. But I'm going to stop there, and because I realized I went a little over time, but thank you all for your attention, and I'm happy to take any questions.
Great. Thanks a lot, Dustin. I'm going to just open it up for questions from all of you. And you can put your hand up or just start talking.
See if any students want to ask a question first.
Okay. Yeah.
Yeah, I had a question.
Hi, Jacob. Nice to meet you.
Hi. So you were talking a lot about like land use and finding these alternate places for solar panels. But as the United States like continues to use more renewable and more solar energy, are we going to run into the issue of not having enough of these alternative lands and like having to like deal with the trade-off of using solar panels in habitat like where animals are and where like plants are?
Yeah, I get the gist of the question. Will we at some point inevitably come up into these conflicts? Do we have enough of the disturbed land? I think we're going to keep seeing the conflicts. I don't know if that's inevitably the case, but I think we're going to keep seeing the conflicts because the mechanisms right now are that developers go after the cheapest place to plug in to the grid. And often those happen to be in areas, at least out west, those happen to be in areas where there's a lot of high quality habitat. Now, according to EPA's Repowering America's database, there should be plenty of, and I haven't looked across all of the states, just looked mainly at some of the west states, there should be plenty of land available for in those degraded habitat, on those degraded landscapes. But the other piece that I think is important, and I've got to find the citation for this again, but a recent paper came out and talked about the amount of corn we grow in this country. And a lot of that corn goes to ethanol production. Mm-hmm. So as we electrify our vehicles, there might be an opportunity to start using some of those agricultural landscapes more for solar production as well. And I think that that's one of the areas that maybe agricultural lands start to retire, is if we start to back off of our ethanol production, maybe some of our corn production diminishes, but that's a little bit unclear. So I guess the short answer is, if we run out of these degraded landscapes, there's plenty of agriculture. And the agriculture, even though I mentioned, there's important habitat in agriculture, some kinds of agriculture are, pretty severely, not good for wildlife. So, developing them into solar farms might even increase, because you could restore. So I've seen some of these solar farms built kind of with restoration in mind, meaning they will try to make that land somewhat habitat. You know, it won't be the same habitat as it would be if it's open space, but it might be better than it would be if it was being disked every year for agriculture, for example. Did that answer your question?
Oh yeah, definitely.
Okay.
Actually, I'd like to follow up with that. Is one of the things you were saying was, you know, the lands that they go after to develop for the solar systems tend to be the ones that are easy to plug in,
Yeah.
near the transmission lines. And so one of the conflicts I know that, you know, we see in different places, hold on, my landlord wants to start, he's repairing the deck and he wants to come up here and start drilling, which would make a lot of noise. So I told him to go away for another is conflicts over building new transmission lines.
Yeah.
And so so that, you know, there's these different potential types of conflicts. And I'm just wondering what you've seen about that, or the potential for building new transmission lines out west, since you're more familiar with that.
Yeah, so this is actually a topic that I'm very interested in also, which, and empirically, I'm not sure it's as hard to build transmission lines out here as people think it is.
Mhm.
And the reason I say that is because I've seen in my time living in California, which is about 20 years, or a little over 20 years, I've seen transmission lines get built. And the question is, why do they take long? So for example, there's one big one called Sunrise Power Link that connects like the Salton Sea area to San Diego. And there's another one that was called the West 10 link, which connects Arizona to California around that solar energy zone, actually, that I mentioned before. And those got new transmission lines relatively easily. Now, they took a little bit longer time because what happens is a developer will take the shortest path and say it's economically unfeasible for us to avoid the state park or the national forest or all these other things. And eventually, like the I-10 West one, that was going to go through some protected area, I forgot the name of it, but they ended up routing it along the highway, went right through. So you know, the question is, where do they start from? Where do they end up? And I think it probably is different on the East Coast. So I think I'm seeing, you know, different dynamics happen there. You got a transmission line, I guess, coming from Quebec that keeps getting rejected.
Right.
But
Yeah.
there's questions about whether or not Quebec's just exporting their hydropower and developing their natural gas for. So there's like a little bit of that leakage, they call it, right? When you know you make claims to be importing clean energy, but where you're importing it from is increasing their dirty energy. So there's a little bit of a shell game going on there. But I mean, the fact is, if we're talking about you know, building the super grid, which a lot of people are talking about, then we're going to need more transmission. The question is how to get the utilities to build it where it's needed. So even right now, you know, there's a big power transmission line being proposed between Las Vegas and Reno. And when they build that, that's going to open up a ton of new areas right along Death Valley for solar development. Now, a lot of people will say, that's great, we need more solar because we can wheel it all over the place. And if we have a big, robust grid, that's going to be helpful. But I'm not sure that that transmission line is a result of the thinking behind how do we design a system to get power from, move it around. I mean, the utility, you know, utilities make money by building transmission lines. That's one way that they can actually mark that up to the ratepayers. So there's kind of there are incentives to build transmission lines that are not necessarily aligned with the idea of building transmission lines to interconnect everybody, I guess is what I'm getting at there.
Yeah. Okay, great.
Complicated.
Yeah, super complicated. Right.
And I think we need more empirical evidence of that. So I think there's a book by a journalist, a Wall Street Journal journalist named Russell Gold called Superpower. And it kind of documents the difficulties of building a transmission line somewhere in the Midwest. And I feel like that's been taken up as the way things are. Whereas I believe if people were to spend some time looking at the empirical case studies, maybe they would find the problems are not environmental impact statements, because that's one of the things that we hear out here is, oh, it's the environmental impact statement process that's causing the delays. And we know that that's definitely not the case. But there are interconnection queues, there are things between the utilities, or I should say the balancing areas that I think need to be worked out. So it's definitely a complicated set of topics that I think we're going to have to keep watching for sure.
Yeah, and I also think what's driving the opposition to them is really complicated, because it's not always about the transmission line.
That's true too, for sure. Yep.
Yeah. I could keep going with that, but I'd like to ask if there's other questions. Sarah, did you have one?
Yeah, no, I was just going to
Great.
pick up on that. And of course, we just had an election on Tuesday, and Maine, third in line after refusals by New Hampshire and Vermont, was trying to get through the power line from Quebec for getting hydro. Again, we can have arguments about hydro, but clearly it's better than the oil that Massachusetts mostly uses. So that just got knocked out of the water, and it's a very complicated set of reasons, in part because we have oil and gas lobby putting a lot of money behind people seeing this as environmentally friendly, wording the ballot issue such that it's a yes, which means no. And so all sorts of tricks at every level that get your average voter totally snowballed confused. And so now that's going into court, right? And again, so that's just one example of the complexity of getting power line through. We're talking about 50 miles of new lines, and that's it, because the rest of it is pretty much on the existing grid. And so, yeah, so that's one example of trying to get stuff through.
Yeah, totally. Yep. That's why I said the East Coast, I think, seems like it has more conflicts than the West Coast, partly because the public lands, I think, help make it easy. Because you're only dealing with one landowner for big swaths of land in many cases, whereas you get a lot of private holders.
Absolutely. And yet, Carrick, I think, is likely to speak to this as well, but we spent 24 years at the University of Wyoming. So we are pretty familiar with the other context, which is not the coast, the rest of the West, because California is a different case. And, you know, you see it a bit in Nevada. Lots of space to put solar, not a lot of connections, still a lot of problems.
Yeah.
So I will just say, yeah, the complexities are a challenge on that one.
Yeah, I mean, for California, so where I'm sitting right now in California, which I forgot to say where I was calling, Papaluchum, which is a unceded territory of the Waswas speaking Ayupi tribe, is where I'm calling you from, or zooming in here from. You know, the challenge is going to be Northern California. Southern California has plenty of renewable energy, and there's a bottleneck from the north to the south of the state. And that's why Wyoming is seen as such an important interconnection for the state. It's either going to, so Northern California is either going to get offshore wind or Wyoming wind, and they sort of need it to, for the state. They don't have much. The onshore wind is not really, it's kind of saturated right now for the same reasons. You have, onshore wind in California. We don't have the best wind resources. We have a bunch of windy kind of spots where we have wind farms, and those areas are saturated. So like you want to build a wind farm there, you're going to wait in line to get your stuff onto the grid, and you might be the first to be curtailed. And when you have when the economic incentive is a production tax credit, wind farms don't want to be turned off ever, because they get a tax credit for every rotation. So like they don't want to have those rotations turned off as happens up in the Pacific Northwest often, where they're curtailed because of the high amount of hydropower that has to flow down the river.
Yeah, just to maybe follow up on the Wyoming situation a little bit. Southern California's got lots of solar, but is actually not necessarily the greatest place for solar in the sense of, photovoltaics, traditional silica photovoltaics are more efficient at lower temperature. And so the high temperatures in the desert are not so great. So up in Wyoming at high altitude and lower temperature and very sunny, you get a much higher capacity factor. But then you lose it when you have to transmit it a long way to a place like California. But then also I don't know where the Anschutz,
Mm,
I remember the name of the big wind development in southern Wyoming that Anschutz was pushing through, $3 billion project, but they had to do a transmission line to get to the California market, which I'm not sure where that stands. But,
Yeah.
it derailed for a while.
yeah, it's been over 10 years that's been in the making, and it's partly because Wyoming policy, right? There's lots of capacity for onshore wind in Wyoming, but Wyoming
Excellent.
instituted a generation tax on wind power over 10 years ago. And so after that, development shut down.
Yep. Yep.
And even for solar, again, best capacity, cold, clear. It's the greatest generation capacity, but they have to decide they want it. And so we get back to political will problems.
Yeah. Plus we've had some catastrophic wildfires caused by our transmission lines.
Yes.
Yeah.
Which makes it's going to make it harder in some ways to build transmission lines unless but they can upgrade them. I mean, that's part of it too.
Yeah.
Yeah. Yeah.
Yeah.
And I often say that with solar technology in particular, obviously, silicon's been around for a very long time, and a very long, development learning curve.
Yeah.
And you mentioned SIGs, cadmium telluride is definitely the big one, of course, as you pointed out. But I think there's a trade-off because, cadmium and tellurium are, toxic, particularly the cadmium. But I think less maybe understood is that in a traditional silicon panel, aside from the silver, the solders, which can also get exposed, have got lead and antimony and bismuth and things like that in them that are not necessarily a less environmental impact than the CAD-TEL.
Yeah, and it's funny, for many years there were some of the SIGs manufacturers who had a cadmium sulfide layer were replacing their cadmium sulfide layer with a zinc sulfide layer. But since zinc mining is where we get cadmium from, some people were arguing it's not really helping in any ways. You're actually creating more cadmium pollution because you're going after more zinc, which leaves you with a bigger pile of cadmium.
I guess comes back to the main point, which I think we're in agreement on, of course, which is that we don't want to come away from this saying solar is bad.
No, right.
Stick with oil and gas. And so it's good to compare the environmental impacts. Nothing is going to have zero environmental impacts.
Correct.
And so, and I think we do have to, as Sarah would say, right, the right site, and we have to accommodate all these things in the wildlife and do a better job of planning and everything. But ultimately, the question is, what are the impacts of climate change and what are the impacts of oil and gas and versus this, and how can we find the best way through a difficult situation?
I think that's it. And that's why I try to frame much of this as just about making this a technology, making this better and not pointing to other, not doing the whataboutism type thing where you say, hey, well, what about natural gas? If you're going to complain about my solar, just make it a little bit better. Like we gotta, that's why I think the standard might help a little bit to show and illustrate. It's funny, even on the land use side, a few years ago, we did a study with the Nature Conservancy to look at some of these mitigation questions, how much land was being used for mitigation, et cetera. And we interviewed a bunch of developers that said they would never touch never touch a parcel that had endangered species on it. So there are certainly people in the industry who are thinking ahead of others. But the blunt economics of things, sometimes the developers that don't care about land are typically companies that are developers and manufacturers. So the more they develop, the more they manufacture. Or two, bigger energy companies that are just doing all sorts of things. I'm thinking NextEra right now, which often gets labeled as the biggest solar and wind company in the world, but they have natural gas investments planned all the way through 2040, build pipelines and all sorts of stuff. So there's a little bit of concern about cost shifting and things like that too. So, but if we can I think we have a lot of opportunity here to make this a lot better, and we have to be out in front of it, because unfortunately, because of the urgency of the climate situation, there is a reluctance to say negative things about solar, even if it
Right.
doesn't, it probably wouldn't give them much of a bad, I don't think bad. I think people are a little over worried about that. Let me put it that way. But that criticizing solar will suddenly lead to us not using it anymore. And I don't think that's the case. I think it would actually get us to think better about things. But because people that don't like solar say whatever they want anyway and believe whatever they want anyway. And it's not really the mainstream groups anyway.
I think another thing that I took from your talk was that it relates to the question about energy justice, climate justice, is, and people see the opportunity for, an energy transition as being an opportunity for more equity, more equality, more sort of a more opportunity to create a more just system,
Right.
at large, is that it's not really about the solar industry per se, or the wind industry per se, because what I took so much is how embedded they are in these larger, for example, the mining, right, the extraction. So they're getting the cadmium from the zinc. So, the zinc mining, it's what's that mining like, and how is that under kind of corporate control, and not very many standards, or, and addressing environmental impacts, et cetera, et cetera, et cetera, labor impacts. So we're not going to get there by just focusing on the renewable energy transition. We have to be focusing on these bigger systems that they're embedded in.
I think that
just makes it
there's something to that. Yeah.
so challenging. Any other questions out there?
I was just going to ask, Jacob and I actually read some chapters of your book for one of our classes, but
Thank you.
hi, sorry. So like I was really infatuated with, we read like solar power or parts of it about like China's dumping, and how like professor, I'm also a graduate student, not at the same level or understanding that my professors are at, but the true impact in that, like it all comes, and why it's so cheap is from China. Yeah, it's pushed to be an American solution to energy that's solely dictated by mining across the globe and manufacturing out of the country, that is brought here to only have land issues from a generation that's only profited off of like outsourcing.
Yeah, that's definitely one of the big challenges here is how to, I mean, we're seeing right now, actually this week, there's more trade hearings because they're talking about putting tariffs again on imported photovoltaic modules for the same reasons that they had in the past, which is, concern that they're actually being sold below market cost and undercutting domestic manufacturing. And we actually see in the infrastructure bill that they're talking about passing, we see lots of bonuses now for domestic content. And it's funny because a decade ago, the United States would go after countries like India for having what's called a domestic content requirement. So like, for example, if you want to be able to sell to or build a solar farm that will allow a utility to meet its renewable portfolio standard quota, they can require that a certain portion of the module be made in the United States or made in India or wherever it's being installed. And the US sees that as anti-trade, the anti-free trade. When you put domestic content requirements, that's a violation of the free trade spirit. And we're gonna have to see now, because it looks like the US has finally realized that probably need some domestic content requirements in our own industry if we want to have a domestic industry. Now, I should caveat this all by saying it's not the end of the world if one country makes all the product, right? We buy all sorts of stuff that comes from China. We buy all sorts of stuff that comes from Southeast Asia, manufacturing places there that we don't criticize the same way that maybe I've taken to solar in this case. But if we really want to get to the scale of solar that we need, we're going to need more of it everywhere. So like, why not grow the domestic industry here too, so that we have an industry, they have an industry, other countries have an industry. India, actually, their domestic content requirements help them grow their own industry in that sense too. So it's an industry that we want to grow. I think having, intervening in the trade issues has some unintended consequences, as I mentioned, possibly causing the Xinjiang forced labor issue, or at least the establishment of polysilicon manufacturing there. But there might be some benefits to it too. So I think we're gonna need manufacturing everywhere of this, partly because the product's made out of glass, and that glass, the farther you ship it, it's heavy. You know, who knows how many are. I always side note here, whenever I see these container ships falling off the ships from China, I'm always curious if there's any of them with solar panels in them. Anyhow.
You know, that actually, just one really quick thought on that. I know we're at the end here, but tying this back to the recycling and the waste issue, where we know that like so many communities have stopped recycling glass. Can we close that part of the loop in terms of those kinds of processed glasses and recycling for energy purposes? Because that seems like a great opportunity waiting to happen.
It sure is, and it's hard. The glass itself is hard to recycle to flat glass. So if we have flat glass and bottle glass, and most of the time, if you're able to recycle glass from a photovoltaic module, it'll end up in bottle glass. Flat glass manufacturing requires specific conditions, and I think they were just worried of contamination of that glass manufacturing process.
What about the other way though? Not the panels, but to get, in other words, to reduce the initial glass for the panels coming from recycled or not yet recycled, or should be recycled but isn't.
Right. Well, that's in the standard, we put a recycled content requirement for that leadership standard. So they have to be using something like 10% recycled content in the glass, which is the idea. Now, I'm not sure how much more that can be ratcheted up with flat glass.
That's what I'm wondering. Yeah.
Like there might be I've read in some trade presses that there's like a little bit of a physical limit to how much recycled material, and often that recycled content number is industrial scrap, not post-consumer scrap. So there's that piece to it too.
In general,
but for some materials, it could be a huge, and I'm thinking batteries here, so I'll jump to a different commodity system for a second. The National Renewable Energy Lab found that if the US recycled their lithium ion batteries, the ones that contain cobalt, not all of them do, but some do, that based on what the projections for those cobalt-based lithium ion batteries are, 60% of the cobalt supply could be augmented by 60% essentially. So we certainly could make big inroads with recovering some of the metals. The problem is that some materials are hard to work with to make them back into the material you started with, or the concentrations of the materials are so low that it's hard to get it out. Like lithium, for example. Lithium, there's not actually much lithium in a lithium ion battery, so not much is recycled right now. Maybe 5% globally of the lithium is recovered, even if other materials from those batteries are being recovered, like manganese and cobalt and such. So it's certainly important for us to be encouraging recycled content, maybe just not domestic content, but also encouraging end-of-life management plan to help that recycled content be realized.
I know we're at the last. I have one question that you might know, but regarding like recycled content, because I've done some work with like e-waste in Agmabloshi in like Africa, but not work. I've worked with a professor of mine to like do some research.
No, I know what you mean. You're learning a lot. Yep.
But is it actually recycled, or is the waste sent to the global south, or is it retained in the global north? Because I know like the e-waste in the global south is actually a lot of people's livelihoods. So if we were to cut off that supply chain, what are we actually going to do? Where that's from the source, like Professor Shell said, would be better.
We don't have any evidence that solar panels are being exported to developing countries. And I think the reason for that is because there's so much glass, and the glass to valuable proportion is very, very high, as opposed to like, wires or computer processors that have a high proportion of valuable material to the actual total mass of the product. So I think that we're not seeing that. But to your point, thinking about those artisanal cobalt mining activities, right? There's a lot of people who when they saw that, we're like, oh, we shouldn't buy from artisanal mining. We shouldn't, because there's all potential child labor and they don't really have any safeguards and all that stuff. But the alternative is buying from mining conglomerates, right? And then what are those folks going to do if they're not selling cobalt? And what's the development strategy to help them get out of poverty if that's the case, if you're going to cut off their only livelihood? So I think that is a dynamic that's really, really important to pay attention to. And it certainly is happening not on the recycled side or e-waste side, but certainly on the material sourcing side for sure, at least in batteries. We don't really see a material like that in the solar industry.
Especially because the Chinese came into the cobalt mines in the Congo to pay off plans. So you're actually funding China twice instead of the livelihood of the local people
that's
tearing up their
fair.
houses.
That totally is fair, right?
All right, thank you. Thanks, Kelly, for your questions.
Yeah, great questions. Thank you.
Yeah.
Yeah.
All right, we're at 3:30, so I want to, honor the time. And Dustin, thank you so much for this talk. It is really interesting. And
I appreciate the opportunity to talk with you, and I hope we stay in touch, and we'll see you down the road sometime.
Yeah, I hope so too. Someday we'll all be able to go places again.
Yeah, I'm gonna go on vacation with you. Sounds like you got some fun traveling plans sometime.
Yeah, right. We all
My
do
kids.
it at WPI. So,
Awesome.
yeah.
Well,
Anyway, so thanks again, and to all of you for coming as well. And have a great weekend.
have a great weekend, everyone. Bye-bye.
Take
Bye.
care. Thanks.